Hey there, my name is Harvey and this is my Calculus and Vector CCT. So the following question that I'll be solving is the one shown right here. So it says refer to question 13. Compare the standard wall socket voltage signals of Europe and North America. Recall that in North America, the voltage is described by the function V of t equals 170 sine 120 pi t. Refer to question 13 and solve for the period in seconds, the frequency in hertz, and the amplitude in volts, as well as the maximum voltage and the times they occur. And the second part is to discuss the similarities between the two functions. And so to go back and to look at the highlighted areas, which are the main ideas in this question. So the main one, first part, is the equation given to us, which once again is the voltage is equal to 170 sine 120 pi t. And the next important points are what the question is asking us to solve, which is the period in seconds, the frequency in hertz, the amplitude in volts, as well as the max and min, and the times they occur. So to start solving this question, we will begin with step 1. And so step 1 will be to solve for the amplitude. So step 1. So the amplitude can be also found as the A value. And so the A value in this case, as we go back to our question, 170 sine 120 pi t. And so the A value within our function is right here, 170. So our amplitude already has been solved, and it is 170 volts. Step 2, which will be solving for the period. So the period can be solved using the equation shown as 2 pi divided by b. And now going back to our equation, our b value is 120 pi. So in order to solve this now, we do 2 pi divided by 120 pi, which is equal to 1 divided by 60. And to make this more simplified, this is equal to 0.016 seconds. Now we have solved for our period. And our next step is to solve for the frequency. Step 3. So the frequency can be solved using the equation 1 divided by t, in which t is the period. And so which we saw before, 1 divided by 1 over 60. Now this can be written as 1 multiplied by 60 divided by 1. And so now we have our frequency, which is 60 hertz. Now, we'll be moving on to step 4, which is solving for our max and min voltage, as well as the times that they occur. So the max can be solved by the equation K plus the absolute value of A. So going back to our equation that was given to us, 170 sine 120 pi t. So in our equation, there's actually no K value. So our max will be solved as so. So 0 plus the absolute value of 170. So our maximum voltage already is 170 volts. Now our minimum is discovered using the equation K minus the absolute value of A. And same thing as how we solve the max, there is no K value, so it'll just be 0 minus the absolute value of A once again. So our minimum voltage is negative 170 volts. Now it is asking us for what times they occur at. So going back, we know that sine t has a period of 2 pi and a maximum at every pi over 2 plus 2 pi, and a minimum at every 3 pi over 2 plus 2 pi. So the major difference between the function is the period. So in our function, v of t equals 170 sine 120 pi over t. So the coefficient in front of t is 120 pi, which means that the function travels 120 times as fast, or completes a period 120 pi times faster than the usual equation of sine over t, sine multiplied sine t. So since sine t has a period of 2 pi, then v of t will make one period in every 2 pi over 120, or 1 over 60, which is where we solved for before. So recall that sine t has a maximum every 1 over 4 of the way along a period. This means that the first maximum will be reached at 1 over 4 times 160, which is equal to 1 over 4 times 160, 1 over 60, which is equal to 1 over 240. So since the function has a period of 1 over 60, then you can continuously add 160 to 1 over 240 to obtain more maxima, which would mean that the maximums are when t equals 4k plus 1 divided by 240, where k is an integer greater than or equal to 0. And now, since a minimum occurs every 3 over 4 of a period, so using similar logic, we can find that t equals 4k plus 3 over t40. And that is how we solve for our minimum. Now, going back to part B of our equation, it is asking us to compare the similarities between the two functions. So, in the question 13, it is a much similar equation between what we have as shown here. So the similarities between the two functions are that both contain a maximum and minimum voltage, as well as both contain a very short period. And so that concludes my Calculus and Vector CCT, and thank you for watching.